Okay, we're going to do some exercises here with the data from problem 41. So if you haven't done it already, take the data from problem 41 and put it into your calculator. You can stop the recording right here. Once you finish that, resume the recording. Okay, so let's go to the data for problem for 41, and here's what we're going to do. We're going to go to get out of the data. Make sure that diagnostic is turned on. I'm going to do that right now. So second of catalog, and then the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Diagnostics turn on. I'm going to do stat calc, one variable stats for L1. It defaults to L1, so I hit enter. So here, X bar is the mean, and S sub X is the standard deviation for the X variables. I'm going to take a picture of these variables so I can refer back to them. I'm going to put the pictures over here, and I'm going to go back to these in a little bit. Okay. Now I'm going to I'm going to clear the screen. I'm going to do stat calc, one variable stats, and I'm going to do it on L2. So I'm going to do second, and then 2, and it'll run them on L2. Now it still uses X bar and S sub X, but we know the difference between them because the numbers, obviously, L2 are the prices and L1 is the years. We can easily tell the difference between those statistics. I take a picture of these. So now I can see the statistics. Oh, you know, one thing I should have recorded. No, I'm going to get that later. So anyway, so I've got the mean and standard deviation for both the X variables and the Y variables. So now I'm going to go back. Let's clear the screen. I'm going to go to stat and then edit. And I'm going to go to L3. And here's what I'm going to do. I'm going to take all the variables in L1, all the data in L1, the X coordinates, and I'm going to subtract the mean from them and then divide by the standard deviation. In other words, I'm going to standardize them. Z, let me go over here, let me tap this, Z equals Y minus mu over sigma. And in this case, Z sub X sub I, so in other words, the Z score for each X coordinate is going to equal X sub I minus X bar over the standard deviation of X. And that's going to give me the Z scores for all the, and I'm going to do the same thing for the Y variables. Z sub Y sub I equals Y sub I each in a particular Y variable minus Y bar over the standard deviation of Y. All right, so let me put my statistics back up here. So here I am I'm going to go to the top of L3. So I'm going to put in a parenthesis, and I'm going to put in L1 minus, I'm going to 6.133, that's probably close enough, 0.13333, close parenthesis, divided by the standard deviation, 3.3777, let's call it 3.777. We can go back and make that an 8. Okay. I hit enter. So now here are all the Z-scores. Now let's go down and look at these Z-scores. A bunch of negative ones. Now these numbers are in ascending order. So the lower numbers are negative and the higher numbers are positive. And this makes sense. This is what we expect. Okay? Now we can analyze these Z-scores in a little bit. Now let's go to L4. And we're going to do the same thing for the Y variables. We're going to go to the top. I'm going to do an open parenthesis. Now I'm going to put in L2 for the Y variables. Second, 2. And I'm going to subtract the mean, which is 8403.8. oops, I made a mistake here. 8403.8, close parenthesis, divided by S sub x, 3333, and let's call it 0.6. So 3333.6, I hit enter. Okay. Now these scores, since we start out with the higher numbers, the positive z-scores are at the top, and then the negative ones tend towards the bottom. Okay, so now we have the data in L1 and L2, the ordered pairs in L1 and L2, and then the z-scores that go with those ordered pairs in L3 and L4. Now let's make some scatter plots and see how they look. So I'm going to do second and y equals, and I'm going to turn this plot on, and it defaults to L1 and L2, and that's fine, and the first icon is the icon for the scatter plot. Now let's review these icons again. This is scatter plot, this is time plot, okay, next. This is histogram, here is the box and whisker plot that we use, the middle in the lower row is the box and whisker which we don't use, and then here is the normal probability plot. Okay, so it's set to L1 and L2, and we're all set. I'll hit zoom, and then 9. Okay, now here we've got clearly linear, fairly strong, and negative association, so it's okay to do correlation on this. It meets the requirements, and there's no outliers. So let me take a picture of this. Okay, now let's do the scatter plot on the residuals. Let's see what the residual scatter plot looks like. Remember, the residuals are taken from the data, so let's see what they look like. So I'm going to hit enter, and I'm going to go down to here. X list, I'll make L3, second 3, and then the Y list is L4, second 4. I hit enter, zoom 9, and notice that it's the shape. All the characteristics of the scatter plot are the same. Let me just take a picture of this. Okay? You can see them side by side. What's different, though, is that whereas the scatter plot for the data is all confined to the first quadrant, you can see that because these are z-scores, we're going to have a bunch of plus or minus pairs because this direction's negative. So these are negative x coordinates and positive y coordinates, and then over here we have a lot of positive x coordinates and negative y coordinates. These are the ordered pairs of the z-scores, and we saw that when we looked at the columns. Okay, the x coordinates started out negative when positive. The y coordinates started out positive when negative because they're z-scores. They're all going to center around 0. Okay, so we know that we can go ahead and do linear regression on these guys. Now, but let's back up a little bit. Okay, we have everything we need to make R by hand. Okay, remember R equals z sub I times z sub x, the sum of z sub x divided by n minus 1. Okay, so just for this one time, just for the sake of the exercise, let's just use L3 and L4 to make R. So if we go back to stat and edit, and we go, now we got L3 and L4, that contains the ordered pairs of z-scores. Let's go up to 5. Now 5 is going to be, what we're going to do is we're going to make this L3 times L4. Okay? L3 times L4. In other words, we're doing z sub I, z sub, I miswrote this. Look at what I did here. Z sub x sub I times z sub y sub I. So in other words, we're multiplying the z-scores with x and y variables, which are in L3 and L4. So I hit enter. And here's the products. So we have to add them up. So we're going to get out of here, and we're going to use a nice little function that's let's see, where is that? Second, and we're going to go to list, and we're going to go to ops, and we're going to go to, where's sum? Where the heck is sum? Oh, math, sum. Okay, 5 for sum. Okay, and we're going to add up. Well, where are all those numbers? L5. So second, 5. Okay, so we added up 5. And now we're going to divide by n minus 1. So how many numbers are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So we're going to divide by 14. And that is R. So it's approximately equal to negative 0.9718, I guess we could call it. Okay. Now, we did this, obviously there's a lot of rounding. We rounded the standard deviations. We rounded the means for the x and y variables. Let's actually run linear regression and see what we get. So we're going to do stat calc 8 on L1 and L2. So we hit enter, and R is, see, okay, we did not bad. Okay, actually, it was almost like within a few thousandths. Okay, so anyway, so there's R. Now, we can make an equation. We can say that estimated z-score for a given y is going to equal R times the z-score for the x-coordinate. Okay, so this is like the first step in making the transition. So in this case, the estimated z-score of the price is going to equal negative 0.9718 times the z-score of the year, or the age. Let's call it age. Actually, that's what they're using, is age, not year. Age. Okay, so so this is the first step. Now, why is the y-intercept? Why is the y-intercept 0? Okay, well, let's look at the graph of the scatter plot. Okay, you can see right here, the line of best fit is going to go right through the origin, and that's because all the points are balanced around 0, 0. The mean of the z-scores is always going to be 0. 0 for the x-coordinates, 0 for the y-coordinates, which means z for y bar and the z for x bar is going to be right at 0. So anyway, so there's no y-intercept, there's just a slope, or the y-intercept is 0. Now, where do we go next with this? Well, we're ready to take the next step, which is construct a line of best fit. And the line of best fit is estimated price. We could write it like this, estimated price equals b sub 0, that's the y-intercept, plus b sub 1 times the given age. All right, now, how do we get b sub 0 and b sub 1? First, we find b sub 1. b sub 1 equals the standard deviation of y over the standard deviation of x times r, or in the other way around, doesn't matter. So b sub 1 is going to equal, well, let's look at our statistics here. B sub 1 is going to equal negative, here, let me put the statistics where they're not going to disappear. Over here, there we go. Okay. No, I didn't want to maximize you. All right, now let's go over here and stay here. There you go. Okay, so it's going to equal negative 0.97, let's use our rounded one, times, okay, the standard deviation of the y variables is 333, no, that's the standard deviation, 333.6, divided by the standard deviation of the x coordinates, which is 3.36 778. Now we're just doing this as an exercise, you understand, okay? You're never going to be expected to do this. Well, you're expected to play with parts of this. Okay, so let's go to the calculator, and we can do this by hand just this one time. So we're going to do clear, and we'll do negative 9718 times 3333.6 divided by 3.3778. Okay, so now there's something clearly wrong there. I left out the decimal for the correlation coefficient. Second insert that. That's going to work better. Okay, so B sub 1 is negative 959.08. Or call it about negative $960, because we're talking about money here, so we do some rounding. Okay, now that's B sub 1. Now we have our B sub 0 is simply going to equal y bar minus B sub 1 times x bar. So B sub 0 is going to equal y bar 8403.8 minus negative 95908 times x bar 6.11333. That's enough threes. So the y-intercept. So here's the y-intercept. So let's do this on the old calculator. So we're going to have, let's clear all this, 8403.8 plus 959.08 times 6.1333. Enter. Okay, so B sub 0 is 14286.1, I'll round up to 13. So, estimated cost, this is how you read it, estimated, and this is how you write it, estimated cost equals 14286.13 plus, or minus, I should say, minus 95908 times age. And what's the meaning of B sub 0? Here's B sub 0. That's how much a car costs when its age is 0. And that makes sense. Okay, that makes sense. And then for every year the car ages, it loses about $960 in value. Now, let's compare these numbers to if we did doing linear regression. I didn't save those numbers. We'll just do a stat calc 8 again and enter. And there's, okay, 142, pretty close, and B is very close. Okay, so that's enough for now.